I'm Shingo Omura. I want to talk about Kubernetes today. And this is agenda. I'm going to talk about brief history of Kubernetes first, and the next, why Kubernetes, and what can be done or what can we get with Kubernetes. And I want to focus user-facing Kubernetes key concepts. And next, I want to introduce some tooling on Kubernetes. And lastly, GPU support, and I would like to touch about Chainer or Chainrman on Kubernetes. So this is brief history of Kubernetes. Kubernetes is container orchestration systems. Roughly stated, it can automatically place a bunch of Docker containers nicely in the cluster. And other open source or commercial systems is available. For example, Mesosphere DCOS, this is based on Apache Mesos, or Docker Swarm is provided by Docker company. And some cloud-based solution also exist, Amazon ECS or Azure Container Service. This is you can select DCOS-based or Kubernetes-based. And Kubernetes is actually originated in Google's cluster manager, Borg. This is not open source. This is Google private cluster manager. And Kubernetes firstly opened in 2014 and hit version 1 in 2015. And at the same time, the project was donated to Cloud Native Computing Foundation. The foundation is under Linux Foundation actually. And under this foundation, about 36 companies discuss about Kubernetes specs. This is really open project. And recently graduated CNCF in 2018. And the latest stable version is 1.9.6. This is actually released today. And next, I would like to move why Kubernetes. Why everybody talk about Kubernetes? I think one of the secret is open community. So I would like to focus their community openness and rapid growth today. So Kubernetes community understand openness and transparency is the core to evolve Kubernetes rapidly and to be a game changer in industries. This is the Kubernetes open engagement model presented in the above presentation the last year, KubeCon, by Sarah Novotny, is a head of open source strategy for GCP at Google. Kubernetes usage evolves by 3 feedback loops, as you see. One is developer loop, one is users loop, and one is vendors loop. As of 2017, 400 meetups in the world, 5,000 plus projects based on Kubernetes, and dozens of products with Kubernetes support, and 25 kilo plus GitHub stars. If you are interested in more detail of the cycle or how to manage Kubernetes community itself, please take a look at this presentation, Kubernetes Superpower. And this is Kubernetes repo stats, 49,000 commits in total, and 1,500 contributors in about 15 time zones, and 25 minutes, one commit per 25 minutes in 2017. And bunch of vendors support or contribute Kubernetes, and bunch of companies adopt Kubernetes as their infrastructure. Maybe you can find OpenAI here. OpenAI started using Kubernetes in 2016 in AWS, and now they operate over 2,500 nodes in Azure. And we have Kubernetes Tokyo meetup. The meetup receives over 300 RSVP every time, which is twice as the capacity. And next, Kubernetes is a real game changer, I think. All cloud vendors provide Kubernetes as a service, and every cloud manager vendor announces Kubernetes support. And this is Google Trends graph. Shows people interested in Kubernetes is extremely high than others. This drop down is Christmas of the last year. So what can we get with Kubernetes? These are 8 features stated in the official document. Automate bin packing. This is not academic sense. Kubernetes doesn't solve bin packing problem, but this state schedule your Docker container smartly, and you can customize the strategy. And Kubernetes provides scaling features and automate rollback and rolling updates. And Kubernetes can provision storage, and you can mount them to your containers. And Kubernetes has self-healing features. It means Kubernetes can restart your container automatically when some failure happens in the pod. And it can have service discovery. It can set up DNS automatically and load balancing feature. And it also provides configuration management and secret management. This is really important in operate service. And moreover, Kubernetes can provide batch execution. This is also important for us. So next, I would like to talk about key concept, particularly user-facing Kubernetes concept. I listed core and important concepts. So first, a pod. This is the heart of Kubernetes, I think. Pod models an application-specific logical host. This blue circle in the honeycomb is a pod. Pod can have multiple containers inside of the pod, and containers in pod can have shared storage as volume. The blue cylinders represents volume, and volume is pluggable. So we can use various volume plugin, NFS, host path, etc. Of course, elastic volume storage in AWS, of course. And pod have a unique virtual IP. We call it cluster IP. And containers, this means containers share the pod resources in the pod. And DNS is available in the cluster. So Kubernetes automatically create DNS entry like that, pod IP, namespace. Namespace is talk about later, and pod cluster local. The cluster endpoint DNS cluster.local is customizable. And next important concept is service. Pod is model. It means pod can be stopped by failures or killed by some reasons. Pod itself can have cluster IP, but it cannot be stable. So how to give stable endpoint to set of pods? This is what service provides. Service defines a logical set of pods and a policy by which to access them, and service routes traffic across a set of pods. And service can also have a cluster IP. And several types of service are available for your purpose. And DNS is also available in the cluster. This is set up automatically. The service name, the namespace, and service cluster.local. So next important concept is labels and label selectors. How to specify the target pods, how service specifies the target pods. Label can be used there. Label is a grouping primitive on Kubernetes objects. Labels are key value pairs. You can put multiple labels to objects. For example, the stage name or application name or its versioning. And labels can be attached to object at creation time or update later. This you can manage labels dynamically. And LabelSelector defines target pods. So service can utilize this to specify the target pods. So next is ReplicaSet. ReplicaSet ensures that a specified number of pod replicas are running at any given time. Not technically, there is a tiny downtime, but ReplicaSet controls a specific number of pods are running. And ReplicaSet manages all the pod with labels that match the selector, as I stated, label selectors, right? And ReplicaSet controller runs on control plane to manage pod targets, detecting pod down or spawning new pods. But ReplicaSet does not support rolling update. This is not so realistic or pragmatic in the production. So deployment was introduced in Kubernetes. Deployment is higher concept than ReplicaSet, and official document recommends using deployment always unless there's no reasons. Deployment provides declarative update, and deployment supports rolling update and rollback by managing ReplicaSet. When rolling update, deployment scale down old ReplicaSet and scale up new ReplicaSet, and then deployment keeps old one for rollback. And next one is ConfigMap and secrets. This is very important to isolate pods definition and configs. Config maps can separate your configurations from your pods definition. For example, configuration files, command line arguments, environment variables, port numbers, etc. And secrets are secret object, namely, which stores sensitive data, password, OAuth tokens, SSH keys, etc. And these are injectable to pods via as volumes. So in this case, pod can have files in the directory, and these can be injectable to pods as environment variables. And next one is namespace. Namespace is a unit for multi-tenancy in Kubernetes. Namespace provides a scope for names, just names. So this is not relates to physical placement, just logical namespace. Names of resources need to be unique within a namespace, but not across namespaces. And namespace is a way to divide cluster resources between multiple users. So we can have resource quota for each namespace. And the final concept, batch job support. Pod itself is intended to be a long-running service, some applications or web server or something. However, we can do job in a Kubernetes cluster, of course. So job is intended to be complete. Job controller runs in control plane and control parallelism. We can set parallelism for the job, and job controller controls retry, detecting failures and spawning. And Cronjob is also supported, so we can set scheduled job. So these are important concept of Kubernetes. So I would like to move to tooling for Kubernetes. I would like to introduce two tools which is handy and you'll use regularly. Kubernetes kubectl or kubectl is an army knife for Kubernetes. It's a main command line tool for Kubernetes. So you can create, list, update, delete all Kubernetes objects, pods, service, everything. So this small command line shows kubectl get pod, lists your pod in the namespace. And the second one is spawn a pod. And the last one is getting container shell kubectl exec. If you want to familiar with Docker exec, this is really easily understand. And the next one is Minikube. This can run a local single node Kubernetes cluster and supported virtual hypervisor or virtual environment, VirtualBox, XHV, I don't know how to read it, or other hypervisor platform. And Minikube start. This spawns a single node Kubernetes cluster in your local, and then kubectl provides you ready. And next, GPU support on Kubernetes. NVIDIA GPU only, but NVIDIA GPU is support by default. This support via device plugin and NVIDIA Docker environment. And you can request and limit GPU resources of your pod, whose name is nvidia.com/GPU. So every configuration in Kubernetes can be written in YAML or JSON. So if you put resource limits, CPU one core or memory in 16 gigabytes in bytes or something, and nvidia.com GPU 2. This allocates 2 GPUs for you, and you can write your own device plugin easily. So we can introduce allocatable device. And lastly, I would like to touch for Chainer or ChainerMN on Kubernetes. So about Chainer job, on single host job, no tricks. You can just spawn your long-running pod, for example, sleep infinity command, and then get your container shell then with kubectl exec. Then you can get shell in a container, so you can run your Python or something. Or you can spawn a job. But ChainerMN, it's complicated. As you know, we need to set up OpenMPI cluster which can SSH together. So small tool could be help. Please refer to kubeOpenMPI or run ContainerMN job section in that document. And Kubernetes official document is really comprehensive. So it's worth to take a look as your first step. And books are also available, and Japanese translation will be published soon in April or something. And if you want to see the latest information, KubeCon 2017 is really helpful. Thank you. Any questions? Okay, thank you very much.